make a rational equation. So rational equations look like this. You take a polynomial, divide it by another polynomial, and it's equal to 0. Okay? And what you're going to do, if they're not all going to be equal to 0, some of them are, some of them aren't, but what you're going to do is you did these in Algebra 2. So the first step is you want to clear all of the fractions out of there. And the way that you clear these fractions is you're going to take the equation and you're going to multiply by the LCD. Multiply by the least common denominator, okay? To clear out all those fractions so you don't have fractions to deal with. Now, when you do that, sometimes you're multiplying the entire equation by a variable. And what happens is when you multiply, an equation by a variable, you can get answers that don't work. So you need to check for, do you remember what they were called, the answers that didn't work?
Extraneous.
Yes, extraneous solutions. Yeah, they show up sometimes. They show up when you solve radical equations. They show up when you solve absolute value equations. And they show up in these too, because the domain's not all real numbers. So you're going to check. Okay, so I've got 4 of them to do. Number 1. We'll start with the easier one and work our way to difficult. Here we go. X plus 3 over x is equal to 4. So here's an equation to solve. We've got to find out what x is. And so what we're going to do is we're going to multiply the entire equation by the LCD. And for this one, this is over 1 and that's over 1. So the LCD for this is x. All right, so we're multiplying by x over 1, really. I'm not going to write all the time over 1. But I just wanted to show you that when you do that, you're multiplying all the numerators, right? Because when you multiply fractions, it's top times top, bottom times bottom. So we'll go ahead and distribute that to all 3 terms. And we get x squared plus, now what happens here is, it's going to reduce out, leaving you with 3. And then here we get 4x. And so now what we've done is we've cleared all our fractions out, and we can solve this. This is a quadratic. Anytime you have a quadratic to solve, bring it all over to one side. So we have x squared minus 4x plus 3 if it's equals 0. If it's factorable, try and factor it. If not, you'll have to do quadratic formula. This one happens to be factorable. What times what's 3 adds up to -4 would be a -3 and a -1. And so our answers would be 3 and 1. Do a quick check on extraneous. Extraneous solutions would have been if I had gotten x 0, because that would have made the denominator 0 in the original problem. But 3 and 1 are perfectly fine. Nothing's extraneous there. Do you remember doing this in Algebra 2? Yeah. Love it. Okay. Number 2. Here we go. Oh, here's a fun one. 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Shh. Okay? Yeah, it got a little bit more difficult, didn't it? All of a sudden, huh? Yeah, we did these last year too, a little bit. So what we're going to do is you first want to start by factoring anything that can be factored. So this right here needs to be factored. That way you can see what the LCD is going to be. I mean, you probably already know because we just factored that a minute ago. So I'm going to rewrite this in factored form. And by the way, make sure you show your work because you are solving algebraically, and so there's a lot of steps. You can solve these graphically by plugging them in and finding intersections, but we don't do that. All right, so this is x minus 1 and x minus 3. So now we're going to go ahead and clear all of our fractions out of there by multiplying everything through by x minus 1 times x minus 3, because that's the LCD. X minus 1 can divide into that, x minus 3 divides into that, and this whole thing divides into that. So that's what it is. All right, on this step, you're now going to multiply all of the numerators by this whole thing, okay? So what happens here is the x minus 1 is going to reduce with this x minus 1, leaving you with 2x times x minus 3. Okay? I'm not writing all of that down and then reducing. You can do that as you go along. Here you get The x minus 3 will reduce with this x minus 3, leaving you with x minus 1. And then over here, the entire thing reduces, leaving you with 2. And you see what we just did? We cleared out all those fractions. They're all gone. And now we have a problem to solve that we can probably solve. Here we go. We get 2x squared minus 6x plus x, and then let's bring that 2 over. So minus 3 equals 0. So then I get 2x squared minus 5x minus 3 equals 0. And I try to factor things first. If it's not factorable, then you can tell and you can use quadratic formula. But this one we can use good old star method. Okay. So 2 times negative 3 goes up top. We haven't done star method in a while. Negative 5 in the bottom, 2 and 2. So 2 numbers that multiply to give me negative 6 that add up to negative 5 would be? Good. Negative 6 and 1. So this reduces to 1 over negative 3. I have that, and I have that. So I get x minus 3, 2x plus 1. Okay, so we're still solving. So x would equal 3 and negative 1/2. Except there's a little bit of a problem. Yeah, if you go back and check the original equation right here, if I plug 3 into there, it's going to give me a 0, okay? So that is extraneous, no bueno. I do want to see that you got that, though, and then you crossed it out, okay? All right, 2 more. Tumor. I have a tumor. All right, number 3. Sorry. It's not a tumor. All right, x plus 1 over x minus 4 equals 0. By the way, if you're ever not sure on if you need to, multiply by what you need to multiply by, you can always subtract x to the other side, and then you get a problem where you just cross multiply. If you have 2 terms like that, it's pretty easy to do. But it's okay. I'm going to go ahead and multiply everything through by x minus 4. Okay, so all the tops, all of it. All right, so it seems like every time we're getting a quadratic to solve. That's not very fun. We get x squared minus 4x plus 1 equals 0. Okay. And then what happens is it's not factorable, so we're going to have to use quadratic formula. Okay. So x is equal to, by the way, if you get imaginary answers, then there's no solution. We're just looking for the real answers here. Okay. Negative b plus or minus square root b squared 4ac all over 2 times a. All right. And then make sure you simplify everything. You rationalize, you reduce, all that stuff. So here we get 4 plus or minus the square root of 12 all over 2, which is 4 plus or minus 2 rad 3 over 2. Because remember, 12 is 4 times 3, and then you take the square root of 4, you get 2 rad 3. And then you can reduce everybody by 2. All 3 of these are reducible by 2, so you divide and you get 2 plus or minus rad 3. Those are your 2 answers. And then check, extraneous. The only extraneous solution would have been 4. Had we gotten 4, that would be extraneous. All right, one last one. This is fast, huh? Number 4. Here we go. X minus 3 over x plus 3 over x plus 2 plus 6 over x squared plus 2x equals 0. All right, last one. So what I would do here is I would start by factoring this. You can factor out a GCF and you get x times x plus 2. So when you factor that, then you can see what the LCD is. So I need an x plus 2, and then I have the whole thing there. So I have x times x plus 2. All right, so we're going to multiply the whole thing by that. Here we go. We do it here, and the x's reduce, leaving us with x minus 3 times x plus 2, which we're going to FOIL out in just a minute, Over here, the x plus 2's reduced, leaving us with 3x. And then here, this is pretty cool, the whole thing reduces, leaving us with plus 6 equals 0. All right, so let's FOIL this out. We get x squared. Our inside-outside gives me 2x minus 3x, which is negative x minus 6 plus 3x plus 6 equals 0. Okay, combine your like terms here. We have x squared. What does that give us? Plus 2x equals 0. Uh-oh. And then factor. And this one's really fun because you get not one, but 2 extraneous solutions. Right? You go back and plug them both in. 0 doesn't work. Negative 2 doesn't work. And so we did all of this for nothing. No solution. No solutions. Hi, Jonah. All right.